people like to just use a scale or a dial indicator to measure the movement of the axes. I prefer to actually run a file, and in this case I have a little 5-inch test file that I've created, and a small diameter in the center to do the Z depth. This way I could do my Z, my X and the Y measurements all at one time. So I'll go in with a pair of dial calipers and get a measurement in my X direction. And I have 5 inches 32 thousandths. So I'm 32 thousandths wide in my X direction. So I'm plus 32. And in the Y direction, it looks to be 16 thousandths. So I'm plus 16 in my Y direction. And my Z, I'll do a quick little measurement here. Here's 3 thousandths. There's 9 thousandths. It looks like I'm about 10 thousandths deep in the Z direction. So I'm plus 10. So I'm 32 in the X, 16 in the Y, and I'm too deep in the Z direction by 10 thousandths, or plus 10. So now we'll go over to the calibrate my axis in Mach 3, and I'll go ahead and show you how to do that now. Okay, let's take a moment and recap what we just did. First off, we created a little test file, and in this case it was 5 inches square. We ran the file, used a pair of dial calipers to check the X, Y, and Z dimensions, and the X was plus 32, the Y was plus 16, Z was plus 10. So all three axes are a little bit out of calibration, with the X-axis being the worst. So now we can go ahead and correct it. We've got some hard numbers we can use to correct this, and this makes this very easy. First off, we're going to go to the settings tab, which is right above your XYZ column, and you can also get to that by hitting alternate 6. The key combination alternate 6 will take you to the setup screen. Once you're at the setup screen, then you want to select the set steps per unit tab, and that's located right above the red reset button, and we'll select that. And another little dialog box will open up, and by default it's showing the X-axis. Since we're going to use all three, I'll go ahead and accept that at this time and say OK. At this point, it's going to ask you how far would you like the X-axis to move. Well, here's a little catch. In my case, because I work from center of job, I'm only going to use half of the 5 inches. So that would be 2.5. So I'll go ahead and enter in 2.5. 2.500. Alright, now your machine has moved the 2.5 inches, or whatever figure you keyed in. And now it's going to ask you, in reality, how far did it move? You ask it to move 2.5, but because we're machining and it's going a little bit big, that's the number you want to use. So in my case, I'm half of 5.032, so that would be 2.516. And again, I'll go ahead and key in that number, 2.516. 2.516. Okay. The next window that appears is going to reset your steps per unit, and this would be the steps per unit under motor tuning. I'm not going to say yes because mine is already keyed in. So, but this is where you would say yes, you would like it to readjust your steps per unit. So at this point you would say yes. Alright? And then it's just a matter of repeating the steps. Y-axis, same thing. Come down, select Y, OK. How far do you want it to move? 2.5 inches. How far did it really move? Well, we were 16 over, so that would be 2.508. 2.508. Remember, I'm working from the center of the job, so I'm dividing everything by 2. Say OK, and again, it comes up and tells you that it's going to reset your steps per unit for your motor tuning to give you the correct travel. So, and you do the same thing for the Z. That's per unit, select Z, OK. How far would you like it to move? Well, 0.25, 0.25. How far did it move? It moved 0.26, 10 thousandths plus. And again, it will come up and adjust the Z motor tuning steps per unit. Okay. So, there we just recalibrated all 3 axes, the X, the Y, and the Z. We were using real numbers. Some folks like to use they'll put a scale down on the table, a metal scale or a tape measure, bring a pointer down, set it on some reference number, and tell it to move some distance. It'll move whatever distance you type it in. And then you just simply read off of the scale where you're really at, key in that number, and have it readjust your motor tuning steps. I like using an actual test file. You can get in there and get real numbers, eliminating the need to interpolate where that pointer is in reality on that scale. Unless you're really good reading from a scale, you could probably be off 15 or 20 thousandths, plus or minus. So that, in a nutshell, folks, is how you set the calibration on your on Mach3. And I know there's been a lot of files published on this, on how to do this. This is a tried and true method that I use. It gives me real numbers, and hopefully you'll find it interesting. If it's something that you like, please use it, and I hope it helps. So, all right. Well, here we are. We have the original test file, the adjusted test file. This one was adjusted 32 thousandths in the X direction, 16 thousandths in the Y, and 10 thousandths in the Z. So let's check it out and see where it's really at. Remember, this is a 5-inch square. Four inches, 997. I don't know if you can see the dial or not. 4 inches, 997. 3 thousandths, not too bad. Let's look and see what it is in a Y. That's 5 inches and 1 thousandths. 5001. So that's plus 1. That was plus minus 3. And let's see what our Z depth is. Remember, the Z was short, or was long by 10 thousandths. Now I have a Z depth of 0.246. So that's within 4 thousandths. We get that so it focuses just a little bit. 0.246. So it's absolutely not perfect, but this is wood. Wood moves with the weather, and I'm quite happy with it. So I think I'm going to call that one good to go.